Hello everyone, welcome back to my channel. So those who haven't subscribed yet, please do subscribe so that it will be a great motivation for you and for me to do more and more videos. I'm actually planning to do histology series. So before moving on to histology series, I would like to discuss about the growth structure. Then we will move on to the microscopic details. Then it will be easy for you. So in this session, I am just trying to say the structure of testis, and it's a favorite short note for most of the exams. And it's very important to know the details, because whenever in Viva or in table discussions we ask, most of the students get stuck up in between. So I would like you all to know the perfect structure of testis. So if you consider a single testis, if it is like this, we are just making a sagittal section. We are just cutting it open like this, and this is the view which you are going to analyze. Okay, so if this is testis with upper end and lower end, upper pole and lower pole, you are just cutting it into two halves and you are just visualizing the features inside. This is the view which I have drawn here. So when we talk about structure of testis, we know testis is having three coverings. Tunica vaginalis, it is the outermost sac-like covering. It is a closed sac. Then you have inner to it tunica albuginea, and finally you have the tunica vasculosa. These are the three coverings of testis: tunica vaginalis, tunica albuginea and tunica vasculosa. So the outermost, the black colored thing, that is actually the tunica vaginalis, and it is a closed sac, so that it has got a parietal outer layer and the visceral layer. This is the visceral layer which is in close contact with the main testicular tissue. And we can see that it is a closed sac. This is a closed sac. And the visceral layer is actually lying in close contact with the testicular tissue. So when we trace this tunica vaginalis, we can see that it is not covering the region of testis which is in close contact with epididymis. Epididymis is seen at the posterior aspect of testis. So in this region where the testis is in close contact with the epididymis, there the tunica vaginalis won't interfere. They will actually stand out of this space. So we can say that the tunica vaginalis is covering the testis from the anterior aspect and also on the sides of the testis, whereas it is absent where the testicular tissue is in close contact with the epidermis. So that is the outermost layer. Then inner to that, after tunica vaginalis, so this is the tunica vaginalis. Now inner to that, this green colored region, that is the tunica albuginea. This is the tunica albuginea. And when we talk about tunica albuginea, it is one important structure which is going to divide the testis into many lobules. So how is it going to divide it into many lobules? So we can see that it is closely investing and it is almost a part of testis, whereas tunica vaginalis we can easily peel off, whereas tunica albuginea is a fibrous layer which is in close contact with the testicular tissue, and in the posterior aspect it is actually forming a fibrous septum known as mediastinum testis. This is known as the mediastinum testis. That is actually seen on the posterior aspect, a thickening of the tunica albuginea. And from this mediastinum testis, you can see that there are many incomplete fibrous septa which is going towards the anterior aspect. This is anterior and this is posterior. Okay, so posteriorly the tunica albuginea is thickened to form the mediastinum testis, and from there you can see the fibrous septa extending anteriorly to meet the tunica albuginea in the anterior and the lateral aspect, so that it divides the testicular tissue into many lobules. And it is said that roughly 200 to 300 lobules are there in a single testis. So at this point I would like to say, we know there are mainly two testis. So the singular is testis. T-E-S-T-I-S means singular, and if you replace this I with E, then you can call it as plural. So I is singular, you can remember it like that. So when you write it like TESTIS, it is one testis, and if you replace I with E, it is plural when you want to mention the two testes. Now we have many lobules inside the testicular tissue, roughly 200 to 300 lobules, and in each lobule you can see that I have drawn something with red colored pen. This red colored thing is known as tunica vasculosa. Tunica vasculosa. Okay, so each lobule is lined in the inner aspect by the third layer, that is the tunica vasculosa. So though we say that they are the three coverings of testis, only the tunica vaginalis is actually forming a cover-like thing, whereas tunica albuginea and tunica vasculosa are actually incorporated into the testicular tissue. Now, what are the structures which you are going to visualize in each lobule? So, we have already mentioned there are mainly 200 to 300 lobules. So, consider one single lobule. If you examine one single lobule, we can see up to 2 to 4 coiled seminiferous tubules. There are mainly 2 to 4 coiled seminiferous tubules, and we know they are lined by the germinal epithelium, which gives rise to the spermatozoa. So the coiled seminiferous tubules are seated in each lobule. In each testicular lobule, you get 2 to 4 seminiferous tubules, and we can see that the coiled tubules are straightened, and as they come out, they join a network of tubules known as rete testis. So in the mediastinum testis, or in the posterior part of the testis, you can see a network of tubules known as rete testis, and the coiled seminiferous tubules are getting straightened and they are joining the rete testis. So the spermatozoa which are formed in the seminiferous tubules are actually transferred through the straight tubules into the rete testis. So what's the function of rete testis? It is actually absorption of the fluid part of the secretions of the from the seminiferous tubules. When they reach the rete testis, the water component is actually absorbed. The fluid component is actually absorbed in the rete testis, and this is the place where the sperms are concentrated, so that only the concentrated portion of sperms are actually transmitted into the epididymis and finally to vas deferens. So it is the concentrating function which is happening in the rete testis. Now from the rete testis we can see efferent ductules, or otherwise known as vasa efferentia. This is otherwise known as vasa efferentia. They are the efferent ductules which are entering into the epididymis. So epididymis has got a head, body and tail which is seen closer to the posterior aspect of the testis. And these direct or straight tubules which are actually coming out of the rete testis, you call it as efferent ductules or vasa efferentia. And finally what happens, they are actually entering into the lobules of the epididymis, and from there you can see another coiled structure which is a single structure known as duct of epididymis. So this duct, when it passes through the epididymis, you call it as duct of epididymis, and once it leaves the epididymis, it is known as vas deferens or ductus deferens. And this vas deferens or ductus deferens will carry the sperm and finally it will get ejaculated. When we think about the length of the seminiferous tubule, each tubule is said to be 60 centimeters. So if we just try to straighten out the entire seminiferous tubules, it is said that the length will be about 500 meters. So this is about the structure of testis in a nutshell. We have the three layers, the tunica vaginalis, tunica albuginea and tunica vasculosa. Tunica vaginalis is a closed sac which is seen in the outer aspect. Then it has got a parietal layer and a visceral layer. Visceral layer is in close relation with the tunica albuginea. Tunica albuginea is actually closely investing the testis, and in the posterior aspect it thickens to form the mediastinum testis, and from there you have the fibrous septa which are actually passing through the testicular tissue onto the anterior aspect, so that the tissue is divided into 200 to 300 lobules, and each lobule will be lined in the inner aspect by the next layer, that is tunica vasculosa, and each lobule contains 2 to 4 seminiferous tubules which are lined by the germinal epithelium, which gives rise to the spermatozoa, and the coil tubules will straighten up as they leave the lobules, and it will be actually draining into a network of tubes that is known as rete testis, and there actually the sperms are concentrated by absorbing the fluid portion, and the concentrated sperms are actually drained into the lobules of the epididymis through straight ducts known as efferent ductules or vasa efferentia, and from there it travels through the epididymis, through the duct of epididymis, and finally it will be going through the ductus deferens or vas deferens, and finally it will get ejaculated. So that's just structure of testis in a nutshell. Please do let me know if it is useful for you. Thank you. Thanks for watching.